Hi everyone, this is the solution to example 16 on rotated vessels. This is the problem. If the Mercury U-tube shown is rotated about a vertical axis through the leg CD, determine the following. So assume no mercury will spill out and that the surfaces are exposed to the atmosphere. First, the angular speed in revolutions per minute when CD has just no mercury remaining. The height in mm of mercury column in the leg AB when the speed is 40 rpm, and the height in mm of mercury column in the leg AB when the speed is 54 rpm. So this is the situation. So for the first question, when CD has just no mercury remaining, so since both surfaces of mercury are exposed to the atmosphere, so the vortex will form on C because it is rotated through the leg CD about that vertical axis. And this content 0.2 mm or 200 mm will be shifted here, or this will go down, and so this rises also by 200 mm. Therefore, the height of this is the parabolic surface, imaginary parabolic surface of zero pressure. So the height of mercury surface, which is paraboloid, is 0.4, 0.2 plus 0.2. So substitute into the formula, 0.4 equals 0.0005589 omega square 0.6 square radius. So omega is 44.59 revolutions per minute. So take note that at this rotational speed, there will be no mercury on leg CD. Just no mercury on leg CD. So when the speed is 40 rpm, which is slower than this, we expect that there will still be mercury remaining on CD. So let's solve for that height. H2 is 0.00055890 40 square 0.6 square. So H2 is equal to 0.3219 meter, which is less than this 0.4 here. So therefore, the paraboloid, imaginary paraboloid or parabolic surface will look as shown in the figure. So the height of this surface is 0.3219. So this one will lower, and it now transfer there with the same amount, y2, then that's also y2. So from the figure, y2 plus y2 equals 0.3219, or 2y2 equals 0.3219 or 321.9 mm, so that y2 is equal to 160.95 mm. Therefore, the height of mercury on leg AB would be 200 plus y2. So height of mercury on leg AB is 200 mm plus y2 in mm. So that would be 360.95. So let's round up that to 361 mm. Then for C, the speed is 54 rpm. So definitely there will be no mercury on leg CD. This is faster, so the height expected would be greater than 0.4. So 0.0005589 times 54 square times 0.6 square. H3 is 0.5867 meter, which is greater than 0.4. So the paraboloid will extend below C here, imaginary. Everything here will push the mercury. So whatever is lost in this leg here, that's also the rising in the leg AB. So this is the figure. So we will call this Y3, this distance as X3. Then the increase in mercury level from B is also 0.2 plus X3. 0.2 plus X3 will transfer here. So this is 0.2 plus X3 meter. Take note, this is 0.2 meter also. Then this vertical distance is 0.5867 meter. So to solve for the height of mercury on leg AB, it is 200 mm plus 200 mm plus x3 mm. But we do not know x3. To solve that, we apply squared property of parabola first. Y3 as 2x3 square equals 0.5867 as to 0 0.6 square. Then the second equation would be from the figure 0.2 plus x3 plus 0.2 meter plus y3, this is y3, equals 0.5867. Again, 0.2 plus x3 plus 0.2 plus y3 equals 0.5867. So x3 plus y3, where y3 is 0.5867 over 0.6 square, times x3 square, then minus 0.5867 equals 0. So x3 plus 1.6297 x3 square, that's y3, minus 0.1867 equals 0. So solving for this quadratic equation for x, the real root of x is 0.15 meter or 150 mm. Therefore, the height of Mercury on leg AB would be 200 plus 200 plus x3. So 200 mm plus 200 mm plus x3 mm. So it is equal to 550 mm. So that's all for this problem. I hope that you are able to understand and follow the solution.